Okay, so what we're going to do is we're going to take a look at this problem, and this is a time value of money problem. They're asking you to compute the net present value. So let's go ahead and do that for this problem. Net present value. Um, Also, I want to point out that the question is, where did this factor come from? 3.7908. Okay, so whenever you do a net present value problem, so for net present value problems, we have to use tables. So if you look in the Wiley Plus, okay, so if you look in the Wiley Plus e-text, you can see here, Appendix G, okay, it says time value of money. Table 4, they have a present value of an annuity table. And if I scroll up, they have a present value of 1 table. So this is table 3 for present value of 1. Table 4 is present value of annuity. We're going to use both of those tables. Okay, so the answer to the question, where did the 3.7 come from? If you look at the present value of an annuity, 10%, right here, 5 periods, it's 3.79. Okay, so that's where that comes from. But let's go through the problem and then kind of work this out. Okay, so in this problem, it says that you have an investment that costs $136,000. So you have to pay $136,000 to get the investment started. The investment is going to last for 5 years. Okay, so these are all important facts. At the end of the 5th year, you're going to sell the investment for $60,000. Okay, so $60,000. And then it says that while you have the investment, you're going to get extra money in the amount of $25,000 per year. Okay, so it says net cash flow, $25,000 per year. And then they give us 2 interest rates, and this is kind of confusing. It says the borrowing rate is 8%, but the cost of capital is 10%. We want to use the cost of capital. Okay, so cost of capital means how much does it cost you if you're going to invest in something. That's called the cost of capital. Okay, we're not borrowing any money in this example, right, necessarily, so you want to ignore this borrowing rate. Okay, okay, so again, to recap, we're getting $136,000. We take that money, we're going to invest it for 5 years, and then what do we get back? Well, we get back $25,000 every year for 5 years, and then we get back $60,000. This is what it looks like in a Excel spreadsheet. You have to invest $136,000. You get that money and you invest it. That's why it's negative here. And then you get $25,000 5 times, right? That's why it's plus 25,000, and you see it 5 times. At the end of the 5th year, you have to you get to sell the investment, and then you get $60,000 back, right? So what are you paying for the investment? It's $136,000. What are you getting back? This is what you get back. So to find the net present value, we want to take all of the future money, all this money in the future here, and then we want to figure out, well, what is that worth like right now? Okay, so to do that, we have to use the table. Okay, so $25,000, we have to convert that into present dollars. We're going to take 25,000 and we're going to multiply it by some factor. Okay, so keep in mind that this 25,000 is the same money every year. The same thing every year is called an annuity. Okay, so we want to use present value of annuity. You use this table to convert money that is an annuity. What's an annuity? When you get the same money every year. Okay, so how many years is this project good for? 5 years. What was the interest rate we're going to use? Use the cost of capital. It's 10%. Okay, so 10%, 5 years, 3.79079. Okay, 3.79079. 3.79079. Okay, so if we do the math here, we get this times this. Okay, so if somebody gave you $25,000 every year for 5 years, 5 times, What would that all be worth like today in today's dollars if you converted it into today's dollars? It would be worth 94,769.8. Okay. So we took care of this part here. What about this part? This 60,000. Is this an annuity? It's not an annuity because it's only one time. Annuity is the same money more than one time. Okay, so this is a single sum. If somebody gives you $60,000 5 years from now, what would that be worth like right now? So we're going to take 60,000 and then multiply by some factor, right? So the factor comes from the table. Which table do we use? Annuity table, or do we use single table? This is table 3 is single. Use the single table. What's the interest rate? 10%. Okay. And how many years? 6 years. 0.62092. 0.622092. Okay, there. Okay, so we take this, multiply by that, and that's what we get. Okay. So let's add these two together. Okay. So all of this money that you get in the future, if you were to figure out what is it worth like right now, it would be worth 132,025. It would be worth this number here. Okay. Okay. Now the final step is net present value. Net means combine everything together. Okay, so what is the present value of all of the money you're going to get in the future? It's here. It's 132,025 minus what is the investment that you have to make to get the project started? 136,000. So that's what it looks like. Let's do the math. And we get negative 3975. This is the final answer. This is the net present value. Okay, so for net present value, it helps to make a timeline. And then money in the future, you have to use the table to figure out what it's worth today. That's how you convert it to today's dollars. Remember, there's two tables. Table 3 is single sum. That's when you have money one time. Table 2 is annuity. That's when you have the same money for more than 1 year. Okay. Combine everything together. Combine everything together to get the net present value.